What is the name of the process occurring in the above experiment? It's when a current is passed breaking up a certain electrolyte into two parts. So you've got ions going to that electrode and ions going to that electrode. If you just unpack it a little bit, the long electrode is the positive one. Oh, sorry, let me rephrase that. The one connected to the positive, to the long side, is positive, and this is negative, which means that this will be attracting the chloride minus ions, and this would be attracting the copper 2 plus ions. What is the name of the process? This is electrolysis. Provide labels for the electrodes A and B. I'm going to just quickly go and say that we've got Cu2 plus gaining 2 electrons and becoming copper. That is the gain of electrons, so it is reduction. And reduction always happens at the cathode. Conversely, we have got the chloride ion losing electrons and becoming chlorine. We need 2 electrons in that to get Cl2 and 2 chlorides. We've got a balance of charge. We have got 2 electrons here and 2 electrons over there. So because this is the loss of electrons, it is oxidation. And oxidation takes place at the anode. What's it? An ox. Right, so providing labels, we've done that. A is the anode, by coincidence, and B is the cathode. Write the ionic equations for the reactions occurring at electrodes A and B respectively. So at A, you've got Cl minus becoming Cl2 plus 2 electrons, and you really should put that little charge over there. And on the copper, we've got copper 2 plus 2 electrons becomes copper. Metal. What energy conversion takes place in the above experiment? It is electrical energy becomes chemical energy, because we break up chemicals using an electric current. Differentiate between the terms oxidation and reduction. This is just definition work. So oxidation is the loss of electrons, and reduction is the gaining of electrons. Would the above experiment work if a sugar solution was used instead of a copper sulfate? Or we didn't even have copper sulfate, we had copper chloride, but anyway, solution was used. Explain your answer. And the answer is no, because sugar is a covalent molecule, unable to ionize in water, and therefore there would be no ions to conduct the electricity. You are investigating the electrical conductivity of a few liquids and solutions. Name 3 liquid solutions which can conduct an electric current. Oh, you could have given me pretty much most ionic, but they do have to be soluble ionic solutions. So something like NaCl, CuCl2, silver nitrate, maybe an acid because acids conduct, maybe a base because bases conduct, anything along those lines. What do these substances all have in common? They all will, in water, have ions that are free to move. And what are such substances called? They are electrolytes. Solutions that can conduct electricity. Write equations to represent the dissociation of the following. So we first need to decide copper is CuCO3. Copper has a valency of 2. Carbonate is a polyatomic ion that you need to know has a valency of 2. So copper carbonate dissociates in the presence of water into Cu2 plus ions and CO3 2 minus ions. Might actually not even be a soluble salt, but there's a dissociation anyway. And then you've got sodium hydroxide, and again we need to double check. Sodium has a valency of 1, hydroxide has a valency of 1, it's NaOH, so it's Na plus plus OH minus in the presence of water. Make a large clear sketch of an electrolytic cell which contains a solution of magnesium bromide connected to a 6-volt battery. Indicate the following on your diagram: the electron flow, the direction of the anode, the cathode, the products that are formed at each electrode, and then write down the oxidation half reaction and the reduction half reaction. This is not too tall an order to ask you to draw because, I mean, it's not a complicated picture. You're just going to put the 2 electrodes into some water over there, and then you're going to put in your 6-volt battery. You then have to label your cathode and your anode. So let's call this the cathode, which is on the negative side. And we'll call this the anode. And at the cathode, the positive ions, Mg2+, are attracted. They gain 2 electrons and they become magnesium. That is the gaining of electrons, so it's where reduction takes place. You've written down the half reaction now. And on the other side, you have got the bromide ion coming and losing electrons to become bromine. I need a 2 there and a 2 there, and that is your oxidation step. If you wanted to, you could have said, I don't think you can say very much more. Have you done everything? Oh, electron flow. So the electrons are going from the negative electrode towards not the negative electrode, they're going from the negative terminal of the cell and coming in at the positive terminal of the cell. Why? This guy lost electrons and those 2 electrons went up there. So that's electron flow. It is different, and you should label it with a little e, by the way, because conventional current is just an arrow, whilst an E on that little arrow is your electron flow, which is exactly opposite to conventional current. Copy and complete a table that compares electrolytic and voltaic cells. I've got a little summary over here, which is pretty cute, of the 2. So here's your electrolytic cell, and here's your voltaic or galvanic cell. Galvanic cell is a spontaneous reaction, whilst your electrolytic cell is a non-spontaneous. Back on the table for oxidation, forwards for reduction, whilst this goes exactly the opposite way around. Here you've got the 2 half cells connected by a salt bridge. Here you've got 1 electrolyte that is being broken up by 2 electrodes. Let's see what they ask over here. Energy transfer in a voltaic cell, you have got chemical energy becoming electrical energy, whilst in a electrolytic cell you have got electrical energy becoming chemical energy. The reduction and cathode, oxidation and reduction, where those happen. So the oxidation is going to always happen at the anode, doesn't matter which one you've got, and the reduction will always happen at the cathode. The difference is, however, that in the case of the electrolytic cell, the anode is going to be the positive electrode, whilst the anode will be a negative electrode in the galvanic cell. And here they've got it here. The anode is the negative terminal, the anode is the positive terminal over there. So it's slightly different because of that. So what you find is the positive and the negative swap in these 2. But anode is always oxidation and cathode is always reduction. Reaction at the anode is going to be in the voltaic cell, it's going to be, the anode is going to be where oxidation takes place, and you always have oxidation and reduction. At the anode you always have oxidation. Number of electrolytes required, you have 2 solutions for the voltaic cell, whilst only 1 for the electrolytic cell. The apparatus needed for the cell, there's a setup, and everyday uses used in batteries. Over here it's used for purifying metals and to plate systems and to break up sodium chloride, or to make chlorine rather. And to create aluminium. I suppose those are some examples.